and welcome back to my channel. Today I'm going to be giving you a crash course on functions of multiple variables. Today we are going to be focusing on differentiating functions of multiple variables and integrating functions of multiple variables. So before we get started, just in case you've never seen the word differentiate before, it basically just means to find the derivative of a function. So if we wanted to differentiate a function of multiple variables, let's say f of x, y, z, we would take the partial derivative. Now this symbol looks a lot like the normal derivative, but the d is a little curvy at the top. And we differentiate to one variable at a time. So we could say we could take dy of this function. And this is then denoted as f sub y of x, y, z. So this means we took the partial derivative of this function with respect to y, and we got this partial derivative. Normally though, to save time, we don't write out the x, y, z. After we do this, we just write it as f sub y, or f sub x, or f sub z, depending upon which variable we have differentiated in respect to. So let's say we want to take the partial derivative of this equation, x cubed y squared z plus y squared z plus x z squared. So we can take the partial derivative with respect to x, y, or z, but not all at once. And when we do this, we treat the other variables as constants. So for example, if we wanted to take the partial derivative with respect to x of this function, we would look at each part of this and only want to focus on x. So here we would get 3x squared y squared z. And now this second value has no x value, so it goes to 0 like a constant. And this last bit here just becomes z squared. And then this is equal to f sub x. Now we can go ahead and differentiate with respect to y and z as well, but it's a little redundant, so I'm not going to get into that. The other thing that we can do with differentiating like this is we can now take the partial derivative of this function here in respect to some other variable. If we wanted to take the partial derivative with respect to y of f sub x, we would look at this function here and we would treat x and z as constants. So when we differentiate with respect to y, we get 6x squared y z plus 0, because this has no y, and so z is a constant by itself, which is then 0. And then this is then denoted as f sub x y. And then if we went through and did the work, we would find that it's equal to f sub yx, or in other words, taking the partial derivative with respect to x of the partial derivative with respect to y. So you could take either partial derivative first and it'd be equal to the same function at the end. Now, if you really wanted to, we could continue and we could take the partial derivative with respect to z of our f sub xy. We would get 6x squared y. And then this is then equal to f sub xy z. And we're done. So integration of functions of multiple variables is just like integration of normal functions of single variables, but you just have to be a little bit more careful and make sure that you're lining up everything correctly. So when we are integrating a function of multiple variables, we have to look at the order in which our dx, dy, dz follows, especially when we are working with definite integrals, because you want to make sure that you line up the integral with the correct dx, dy, dz value. When you see this, the inside variables are together and the outside variables are together. When we are working with indefinite integrals, it doesn't really matter which order you take the integral from, whether you integrate with respect to x or integrate with respect to y, it doesn't matter which. But when you are working with definite integrals, you want to make sure you get everything lined up correctly. Just imagine that there are parentheses surrounding each of the different parts of the integral in order to get them all correctly oriented. So for example, we want to take the definite integral of this function 9x squared y squared dx dy. So first thing that we want to do, I'm going to go ahead and draw in some parentheses so we can look at just the inside integral first. So when we integrate with respect to x, we get 3x cubed y squared from x equals 1 to 2 inside this definite integral. So then we're just going to evaluate this. So we're left with the definite integral from 0 to 2 of 21y squared dy, and then you can just integrate this like normal. And then when we go ahead and integrate and plug in our values, we get that our answer is 56. And we're done. So when we're working with indefinite integrals, we still want to make sure to add our c, or plus c at the end. And when you do this, you're going to add a plus c sub 1, c sub 2, c sub 3, depending upon how many variables you have. And then you're going to treat that like a constant and differentiate like normal. So here, this then becomes x cubed y cubed plus y c1 plus c2. And that's it. Thank you so much for watching. This has actually been part of my final project for my maths degree. If you have any questions, I'd be more than happy to answer them in the comments below. Once again, thank you so much for watching and have a great day.